Alright, this video is for the last lesson of the unit. Lesson 5, we're going to be graphing, doing multi-step graphing with all the transformation rules. So we're going to put everything together. And I'll always give you a parent function that you can compare to. But what we're going to do is we're going to state the transformations that happened in the equation. And then one at a time, we're going to graph each transformation so that we can get the final result at the end. You are welcome to always skip to the end, but I will do them one by one. All right, so here, stating the rules. I always start with the negative. I start on the left. That negative in front of the whole equation is a reflection over the x-axis. So we're going to do one thing at a time. We're going to write each transformation over each graph, and then we'll graph them. The next transformation we'll have will be the plus 5 inside the parentheses. Plus inside means that your graph went left 5. And then on the end, the minus 2 on the outside means your graph goes down 2. So let's take this parent function, this blue graph here, and we'll reflect it over the x-axis. Remember, this is the x-axis, so you're taking every point and flipping them upside down. So the origin stays put. This 1, positive 1, if I'm 1 above the x-axis, is now going to be 1 below the x-axis on either side. The next point's I'm 4 above, so I'm now going to be 4 below. And then these last ones are 9 above, so I'm going to be 3, negative 9. That's your first graph. That's the reflect. Oh, I didn't make that perfect, but, oops. There you go. So that one is reflected upside down. All right, now we're going to take each of these points. I'm going to darken them in so we can see them. And we're going to take each of those points and move them to the left 5 units. If you need to slow down from what I'm doing, go ahead and do that. I'm going to start at the origin. I'm going to move it to the left 5. And every point from there will be left 5. Now I'm going a little faster because I'm using the pattern of the parent function. Out 1, down 1, out 2, down 4. But if you want to just translate each point one by one, you will end up with the same graph. So if you have to hit pause, go ahead and hit pause to do that. All right, finally, take that second graph. We're going to move those points down 2. So we should just be down 2 from everything that you started with. All right, and that's all that's going to fit on my graph. So this last one is your final answer. All right, again, hit pause if you need to go a little slower on the graphing. The next graph, 1/2 times negative x squared minus 4. Well, I'm going to start with the 1/2 in front. The 1/2 in front is a vertical compression. I'm going to abbreviate by 1/2. The negative on the inside of the parentheses is a reflection over the y-axis when you're inside the parentheses. And then lastly, the minus 4 on the end means your graph is going to go down 4. So let's start with the vertical compression by 1/2. The vertical compression takes all the y values and multiplies them by 1/2. It never changes the origin, so that point's always the same. Now the first y values here on my first points are at 1. Half of 1 is 1/2. So your x's stay the same. You still go out 1, but only up 1/2. These next points here on my graph, the y value is at 4, and half of 4 is 2. So you'll plot the point 2, 2. All right, my third point, their y value is at 9. Half of 9 is 4.5. So at 3, you're going to go up 3, up 4.5. And that graph is a compressed by 1/2 graph. Okay, I'm going to redo the points here so we can see them for the next picture. Now when I reflect over the y-axis, the vertical axis here that I just drew on, that's the y-axis. So when I flip over it, I'm actually symmetric because that's actually the axis of symmetry through the graph. So what I can actually do, you can redraw it if you want, but we can skip over it because the graph's going to look exactly the same when I reflect that one over the y-axis. And I'll end up just moving this whole graph down 4. All right, so you're just going to translate each point down 4 units and you should end up with a parabola that is compressed, but down just a little. All right, next one. Negative 2x squared plus 5. Start with the negative in front. The negative in front is a reflection over the x-axis. All right, so you're going to take your parent function here and reflect again over the x-axis. So your parabola is going to be the same parent function, same distances for each point, but flipped upside down. So you can go ahead and plot those points there. Go ahead and pause the video if you need to. The next point, the 2. Well, that 2 is in front of the x. It's multiplied. So that is a vertical stretch by 2, which means your y values are getting 2 bigger. So if I look at all my y values here, the first one starts at 0. That one's not going to change when I stretch it. The next y values are at negative 1. If I multiply negative 1 by 2, I get negative 2. So my points, I'm going to go out 1, down 2. These next y values are at negative 4. When I multiply that by 2, I get negative 8. So I'll be at 2, negative 8. And then the last one's here at negative 9. Multiplied by 2 would be negative 18. That would be way down here, but those don't fit on our grid. So we can go ahead and just plot the skinny little parabola right there. And lastly, the plus 5 on the end, that means your graph went up 5. So we're going up 5 here. So we're going to take all of those points and just move them up 5. So instead of negative 8, we'd be at negative 3, which is right here. And I think that would be the whole parabola we can plot. All right, flip your paper over. We have one more of those and then a couple of different problems. Start with the 3 in front. The 3 in front is 3 is bigger than 1, the absolute value of it, so that's going to be a vertical stretch. We're going to vertically stretch it by 3. Okay, so I'm going to take this graph, and again, I'm going to multiply the y values of 0, 1, 4, 9. 0 times 3 is 0. 1 times 1 is 3, so we have 1, 3 on either side. 4 times 3 is 12, so we'll be at 2, 12. I'm going to estimate that, but that one's off our grid. So we have this really skinny parabola here. That's our new parabola, super skinny. We're going to go now minus 4 in the parentheses, means that your graph is going to go to the right 4. So you're going to take each of those points and just move them over 4. Okay, so again, it's really skinny. You can only really plot 3 points on the grid there, but that would be your new parabola. I know that one's not super neat, but that's okay. And then up 1, that plus 1 on the end means you go up 1. All right, so I go from 4, 0 to 4, 1, out 1, up 3 on either side. That would be your final graph. All right, so you should be able to identify the transformations and then step-by-step graph them. Next, we're going to be just stating the transformations. You're always given the parent function, which is the one here in blue, and then you should be able to write the equation. All right, so it looks like my graph, it didn't flip. It just looks like it went strictly to the left. It went left 3 and down 4. If I look at the pattern here, I go out 1, up 1, so it didn't stretch or compress. So all I have to do is write an equation that goes left and down. Left is inside the parentheses. Left goes plus 3 with a square, and down 4 is a minus outside of the parentheses. Number 6 here, it looks like my graph is upside down. So because I flipped, that means that I have a reflection over the x-axis. It does look like my graph went to the right. So it goes right 4. It went up 3. And if I look at the pattern here, from the vertex, my graph goes out 1, down 2. So that graph was vertically stretched by 2. So you have to take all 4 of those and write an equation. Y equals. Well, the first thing you always do is your reflection. When I reflect over the x-axis, there's a negative in front of everything. The next thing that has to go in front of the parentheses is the vertical stretch by 2. So I have a negative 2 in front of my parentheses. I have parentheses because I go to the right, and right would be x minus 4, square the quantity, and then up 3 is a plus 3. Last problem here on the notes. Right, I'm not flipped over, so I don't have a reflection. It does look like I went left 5 and down 2. When I look at the pattern, I go out 1, up a fraction. I can't tell right there. So I'm going to go out 2. So I go out 2, up 2. Remember, normally I go out 2, up 4. 2 is half of 4, so this is a vertical compression by 1/2. When I write the equation, here the compression comes first, so I'll put a 1/2 in front. I did go left, so that goes in the parentheses as a plus 5. Square your quantity, and then down 2 is on the outside. All right, let your teacher know if you have questions. There is practice associated with this, so give that a shot, and then we'll be ready to work on our test review.